Hi everyone, welcome to this GCSE Maths live group tutorial on proportion. Hopefully you're all joining us okay. Looks like lots of you are here today, which is fantastic, and lots of you who have joined us before. So welcome back. I'm Tilly. I'll be here throughout to answer any questions. I work at my tutor, so if you have any questions about the online school, just let me know. And this session will be 1 hour long as usual, so it will finish at 1:15. And as usual, it will be recorded, so you'll be able to watch this back on YouTube, and you can catch up with any previous recordings of tutorials there. There's lots of content there, as well as some shorter clips that our tutors have recorded that sort of give you a little bite-sized taste of the topics covered in these longer tutorials. So check those out if you'd like. So Molly is our tutor today. Lots of you know her really well already. She's a fantastic tutor who's been with my tutor for a really long time. And just a bit about Molly, she studies computer science and mathematics at the University of Bath. So I'll just wait a couple of moments whilst a few last people join us, and please feel free to put any questions in the chat or the Q&A box throughout. And don't worry if your question isn't answered at the time you post it. Molly will be keeping an eye on the chat, and also I'll be making sure to collect any questions to answer in a sort of short Q&A at the end of the session. So if we're all ready to go, then let's get started and have a really good session, guys.
Cool. Hello everyone, I'm Molly, and I just realised I'm wearing the same top as I am in this picture of me, which really made me laugh. I swear I own more clothes than that. Today we're going over proportion. We did cover this a bit last week, so some of it might seem a bit repetitive, but hopefully I'm going to dive even deeper, do a lot more questions, because I know that it's one of the topics that I personally struggled the most with when I was doing my GCSEs, and I think a lot of people found it quite confusing. So hopefully, if you haven't done it before, then this will be good, and if you did it last week and didn't get it, hopefully by the end of this session, you'll get it. Cool, so let's dive in basically. So proportion is a concept that you kind of need to understand before you really answer questions, and I think that it's something that's not always kind of explicitly explained. So proportion basically means the relationship between two variables, and we can represent these on a graph or in terms of an equation. So for example, if we have something like this, this means that y is directly proportional to x. If this is y and this is x. Proportional to x. And it would be the same if the line was like this, if the line was like this, if it was like this. Basically, the fact that it's a straight line tells you it's directly proportional. That means that if y, say, doubles, x doubles. So it's kind of increasing at this similar rate. And the slope of the line, whether it's x is much bigger than y or not much bigger than y or the same as y even, that's called the constant of proportionality. And if you remember from last week, that's this k that we're looking for. Don't worry if you don't know what I'm on about, I'll explain it in a moment. So maybe this doesn't make any sense to you. Hopefully it will by the end. But yeah, it's basically just saying the relationship between x and y. So for example, we could have the relationship y equals 2x. And all that means, so then say if x is 1, y is 2. If x is 4, y is 8. So it's increasing at this rate here. X is quadrupled, so y has quadrupled. And we can have different relationships. We can have y is directly proportional to x squared. We can have y is directly proportional to the square root of x. We can even have y is inversely proportional to x, which we'll talk about in a bit. So hopefully this makes some sort of sense. And what we're going to do today is basically look at how we find this, because that's the main thing. Because as soon as you know what this number is, You only need to know y or x, and you can figure out the other one. So I'll show you how to do that. I think the best way is just to kind of jump in with a question probably and talk you through the question. So those are some quite wordy ones. We'll just have a look at one of these to start with. Now I think some of these we've done before. Yeah, I think we did this last week, but I'll go over it again. I don't think there's any harm in doing that. But I will be going over some different questions and, as I said, some harder questions as well. So let's have a look at this one. We're just going to be looking at part A. So these questions all normally take the same kind of format. It tells you the relationship. It will tell you one case. So this is the relationship. T is directly proportional to M. Then it tells you one case. So when M is 250, T is 600. And then it asks you the question. So what we really need to do is find this K. So what we say is that T is directly proportional to M. Now this, if you might remember it from last week, I call it the funny fish sign. It just means is directly proportional to, or is proportional to. I don't know, it's just how we write it. I don't know why, but it is. But this just kind of gets in my head, what is proportional to what? And basically what this actually means, here we've got it in a real world kind of situation. It means that it's directly proportional, so it's just kind of a linear relationship, one of those straight lines. And this is saying that if we double the mass of the water, we're going to double the amount of time taken. If we halve the amount of water, we halve the amount of time taken. But we want to know what the values are to begin with, right? So we can tell from this straight away. If this said find T when M is 500, we would know that T would be 1,200 because we so directly proportional to with equals K. So it sounds a bit weird. I'll explain why. So T equals Km. Now all this is, you know, when we were looking up here, it's just y equals Kx. We just want to know how to find out K. Now, the way to find out K is by using this second bit of information. You know, I said they'll always give you one case where you have both bits. We want to know K by doing 600 divided by 250. And that will give you, I think it worked quite well last time, bringing up the calculator on here so that you can see what I'm doing. 600 divided by 250, 2.4. And now we can ignore that. That bit in green, that was just to help us find K. Because now what we can do is we can write out this, but with our value of K. So T equals 2.4 M. So this is like before we had y equals 2x. This is like y equals 2.4x. So it's just a straight line, but with a different slope. And now this means, given any value of T, we can find M, and given any value of M, we can find T. So now we've got this K, it's kind of magic. We can do any problem now. So now we have a look at the actual question here. Find T when M equals 400. Well, all we do is plug it in to this equation that we now have. So T equals 2.4 times M, and M is given as 400. So to find T, we just have to do 2.4 times 400. And that will be 2.4 times 400, 960. So a few of you got that really early on, which is fantastic. Hopefully that makes sense. Yeah, how to do that. Someone said, what does that say next to T? I assume you mean here. That was just me trying to draw an arrow to show you that this bit in pink is this bit in pink, what I'm doing here. Cool. We'll have a look at another similar question now. Let's have a look at this one. This is a good one. So, the relationship between two values does not have to be linear. It doesn't always have to be a straight line. D is proportional to S squared. So what this means is that now we have a square relationship. So what this means is that it's going to be a line in the form y equals kx squared, right? Just how before it was y equals kx, now it's y equals kx squared. So we have a relationship that looks like this. And this is important because we'll have to be doing, we'll have to be spotting things on graphs soon. Like kind of seeing a graph and saying, what relationship does this say? What is y proportional to? It'll make sense when I cover that. So what this means is that, so let's give an example. This isn't related to the question at the moment. This is just talking about being proportional to x squared. So let's say that we have y equals 3x squared. Let's say that's our relationship. Well, that means that when x equals 1, y equals 3. But when x equals 2, y equals 12. And what you can see here, in fact, I'll just do one more. I'll say when x equals, I'll say when x equals 3, y equals 27. And what's happened here is that here we've multiplied x by 2. So if it was just proportional, y would be multiplied by 2, but it's proportional to the square. So y multiplies by 2 squared. And going here, we've multiplied x by 3. So y is multiplied by 3 squared. So this is all this means when x doubles, y increases with a factor of 2 squared of 4. If x triples, y is times by 9. Hopefully that makes a bit of sense. That's all this means, is that the rate at which y increases when x increases. So we're going to answer this question in exactly the same way, really. Just move the question over here. So we'll start by doing the same thing that we did at the beginning of the last question. We're just going to write down what we see. So D is proportional, funny fish thing, to S squared. In this case, we don't know what these values are. They're just two variables. And remember, we replace our funny fish symbol with equals K. And when we're thinking out the graph, remember that's just because it's y equals K S squared. You don't have to even do this step. If you understand straight away how to get to here, that's fine. I always find it useful to, because this kind of almost reads like a sentence, right? D is proportional to S squared. And then you just replace this with equals K. I think it's just a way of remembering what it is you have to do. Someone said, what does the... Okay, first of all, someone said, what does the K mean? It's the constant of proportionality. So it's basically the gradient of the line. Or in this case, with the squared, it's how quickly it increases. So whether it's 3 times x squared or 4 times x squared. So if we have two examples, so say y equals a half x squared, in both of these cases, y is proportional to x squared, but this k value is different. So we just set it up, we use k as a placeholder because we don't actually know what the k value is yet. We don't know what that is. Someone said, what's the actual name for the funny fish symbol? That's a very good question. I don't know, but Google will. Proportional to symbol. Doesn't tell me. It's probably some Greek letter, to be honest. I'll tell you what, I will... Oh, it doesn't tell me. Maybe it's not a thing. Who knows? I'm not 100% sure. You don't really need to know. Research it if you want to. It's a widely used thing. It's not just something that I use. So you'll be able to Google it. And somebody said, what does proportion mean? It means that, it basically means that you can draw a graph of the values between them. So if y is proportional to x, then we know the value of y if we know the value of x. For example, if it was just random points and we couldn't actually draw any sort of graph between them, they wouldn't be proportional. But when it's increasing at a very clear rate that's the same, I hope that makes some sort of sense. It's quite difficult. Someone said it's alpha. I don't think it is an alpha. An alpha is this. This symbol is this. Maybe it is. Go ahead and research it if you want to. K can be replaced with any letter, yeah. But K is what is widely used. Like K is not just something I've come up with. K is what mathematicians use. I promise we will do this question. This is quite a lot of really good questions. And someone said, how do you know if it's directly or indirectly proportional? That means, does the line go through the origin? That's a really good question, actually. In this case, it's directly proportional. Directly proportional just means that if one is 0, the other is 0. So if we have a relationship like this, that's directly proportional. If we have a relationship like this, that's indirectly proportional. I don't know if you need to know that, but it's pretty interesting. So there's like this kind of offset thing. So a lot of common cases will be directly proportional. For example, with our question up here, oh gosh, I've zoomed in a lot, that this was about the time taken to heat water based on the mass of water. Obviously, if you have 0 kilograms of water, it's going to take 0 seconds. So that is directly proportional. So that's normally how you can tell. Okay, cool. So, sorry, I keep getting so many notifications. So popular. So yeah, let's continue with this question for now. I'll come back to some questions at the end. So we've set up our thing, d equals ks squared. And now we just want to find the value of k. So just like before, we're going to do that based on this bit here. So this is a really classic setup for a question. D is proportional to something, 2 values, find this. This is a very, very classic question. So let's just plug these values in. So D is 900 when S is 20. So equals K times 20 squared. So now we just find K. So 20 squared is 400. So K equals, so 900 divided by 400, I'm going to keep that as just 4/9. If you put it into your calculator, it will give you this as a 9/4. Sorry. Because 900 divided by 400, 9/4. And the reason I'm going to do that is because I don't, this will give me a recurring decimal. And that means that I could lose some accuracy. So I'd rather keep it as a fraction. This is its exact value. And it's no different, really. So now we can rewrite out this. So D now equals 9/4 times S squared. So all of this work was just to work out what K was. And now that we've got this, they could ask us a million questions. They could say, what's D when S is 25? What's D when S is 1,000,000? What's D when S is 0.1? They could even ask what value of S gives D as 10, or so on. Because we've got this formula, we know everything about this relationship. So now we can work out this, which for that we just plug in 25. So D equals 9/4 times 25 squared. So now we'll just pop this into the calculator. So 25 squared times 9 divided by 4. Obviously on your calculator you'll be able to put that in as a fraction and whatever. Because I'm on this calculator, it's different. So 1406.25. So D equals 1406.25. So hopefully a couple of you got that early, actually. Perfect. Cool. Okay, let's talk about inverse proportion. How exciting. Let me find one that talks about inverse proportion. Here we go. Again, a classic one. You'll see that so many of them are set up like this. It's generally the way that these questions are done. So P is inversely proportional to M. P is 48 when M is 9, so that's our bit of information to help us find K. Calculate the value of P when M equals 12. That's the question. So all this means is that, so P being inversely proportional means that P is proportional to 1 over M. So basically, as M is increasing, P is decreasing. And the graph for this, I'll just go to the side to demonstrate this, because it's going to be y equals k lots of 1 over x. This is just something that you'll have to learn, and I will explain the graph actually because it's quite interesting. The graph looks like this. So that's quite bad. This is just a classic y equals 1 over x graph. And the reason is, at 0 here, it's undefined. These just tend towards 0. They never actually reach it. Because if you try to do y equals 1 over 0, you get undefined. Your calculator will scream at you. However, as we get really, really, really small, really tiny x values, so y equals 1 over 0.0000001, then y gets massive, right? And the same in the negative direction. If you get really small negative, y is a huge negative. And the same if x is huge. If it's y is 1 over a million, y gets really small. So hopefully that makes some sort of sense. Don't worry if you don't fully get that, but just know that this is the graph for y equals 1 over x. So this is our, again, the proportion. This k value will just kind of change the stretch of it. So we need to find the k to be able to work it out. So for example, let's do, again, this is unrelated to this question. I'm just talking about inverse proportionality. So let's say y equals, what should we go for? Let's go for 3 again. 3 lots of 1 over x, which you can just write as y equals 3 over x. So this is this graph, but a bit stretched or something. So let's think about some values. When x is 1, y is 3. When x is 2, y is 3 over 2. So I'd probably normally write that as 3 over 2. I'll write it as 1.5 well, just so that you can see both ways. And what we can see here is that when x doubles, y halves. And if x was to be multiplied by 3, y would be divided by 3. So it's this inverse relationship. So if you remember what we've gone through so far, our direct proportionality meant that if x doubles, y doubles. Square means that if x doubles, y quadruples, because that's 2 squared. And with inverse proportionality, if x doubles, y halves. Hopefully that makes some sense. That's what this proportionality means, is that you know what's happening to y if you know what's happening to x. So let's have a look at this question that we'll do in the same way. So we'll replace our fish symbol with p equals k lots of 1 over m. Now you can keep it like that. I prefer to write it like this. P equals k over m. Let me know if you want me to explain that. It's just because when we do fractions, we multiply just the top. So now we're going to go over here and think about this sentence that we've been given. P equals 48 when m equals 9. So now let's work out k. P is 48 when m is 9. All I've done is I've taken this and I've replaced the values of p with 48 and m, with 9. So now we can work out k. So I'm going to do that by multiplying up by 9 on both sides, so that I get k equals, let's see, 48 times 9, 432. So that's our value of k. So now we ignore that bit and we go over here and we can say p equals 432 over m. So this is like if our, on our graph, it's just stretched quite a lot in one way. You know, y equals 432 over x. It's still this inverse relationship. It's still just some multiple of y equals 1 over x. So now we do the same thing. We want to calculate the value of p when m is 12. So we say p equals 432 divided by 12. So let's go ahead and do that. 432 divided by 12, 36. Which I think quite a lot of you got, which is really good. So you can see all of these questions, they're essentially the same thing, because you just have to work out what your equation is in terms of k, work out k, and then plug values in. So proportion isn't as scary as it seems, and I hope that this is making sense and kind of proving to you that it's not too scary. Okay, let's have a go at some slightly harder questions. Okay, let's have a go at this one. This is a long question. I might regret this, but I think it's really good to show you, because these questions, oh my gosh, I used to get into an exam, see a question like this and want to close the paper. You know, when you see something like this, your brain immediately goes, too many words. But we'll go through it slowly, write out what we know, and you'll see that it's exactly the same thing. I hope. So let's read it through once, just quickly, to visualize what's happening. So a pebble's being thrown vertically upwards and has an initial speed of u meters per second. So that's just the speed that it is how hard I throw it. It reaches a maximum height of h meters before falling vertically downwards. And it's known that h is directly proportional to u squared. So if I throw it, it will reach a certain height. If I throw it twice as hard, it will reach 4 times the height, because it's proportional to the square. Think about that for a moment, go back if you don't fully understand that. And then here, so what we've really got is that this first bit is just explanation. This bit tells us our proportionality. This bit tells us our first case. And then this is our question. So there's a lot of words, but really it's just disguised as a question that we know. We know how to do this. So h is directly proportional to u squared. So h equals k u squared. It's a multiple of u squared. How are we going to work out what that value is? We're going to use this sentence here. When the pebble is thrown at an initial speed of 10 meters per second, so when u is 10, it reaches a maximum height of 5 meters. So when u is 10, h is 5. So 5 equals k times 10 squared. All I've done there is I replaced h with 5 from this and u with 10 from this. So now I can see 5 equals k times 100. So k is going to be 5 divided by 100. Let's see what that gives us. 0.05. So there's our constant there. So now we can rewrite this and say that h equals 0.05 u squared. So now we've got our magic equation. Now we want to find the maximum height reached when the pebble is thrown with an initial speed of 12 meters. And that sounds like a scary sentence, but all it means is find h when u is 12. So we say h equals 0.05 times 12 squared. So let's go ahead and put that in. So I know that 12 squared is 144. So our h value is 7.2. And we've got to remember the unit here. Well, we've been working meters the whole time, so it reaches a height of 7.2 meters. So hopefully you can see that even though that had, yeah, cool. Hopefully you can see that It's just a normal question. It's disguised as a really horrible, almost physicsy question, but it's really not. We've done exactly the same thing that we've done for every other question. Now let's have a look quickly at part B of this one, because this is quite interesting. So part B is asking us to find the initial speed of the pebble if the maximum height reached is 16 meters. Now again, it's horrible, it's words, we don't like words in maths, but all this means is find u when h is 16. And we can kind of read that from it. Find the initial speed of the pebble, that means find u. If the maximum height reached, if h is 16. That's all it is. We've just got to work out what they're saying. So now we've done all of the hard work in the first part of the question. We know this formula, h equals 0.05 u squared. That's the same throughout. So now we just need to work out u when h is 16. So we say 16 equals 0.05 u squared. So u squared, I'm just going to divide by 0.05 on both sides. So 16 divided by 0.05, 320. And then to get u, I'm going to square root this. So 320, where's my square root? 320 square root. I'll just do this to, what does it say to do it to? Oh, it doesn't. I'll just do it to one decimal place. So 17.9. Now the key thing is that when you square root something, it's plus or minus. And that's because, for example, if you square root 4, well, 2 squared is 4, but minus 2 squared is also 4. Now this is important because you need to show that you know that it could be plus or minus, but you can't really throw something with a negative speed. Speed has to be positive. So that means that we disregard our negative value. So we say that u equals 17.9 meters per second. So you can do it the other way around as well. Yeah, perfect. Loads of you are getting that, which is really good. Yeah, people are asking for a similar one. Yeah, I'll do another kind of wordy question, because I think wordy questions are always the scariest, but it's all about realizing that all they're doing is they're just making it look fancy with words, when it's not. It's just the same as all those other simple ones that we were doing. I'll do one more wordy one, and then I'm going to go over a bit of graph stuff. Right, let's find a long wordy one. Okay, let's do this. This looks disgusting, so let's do it. Okay. So, oh, this is cool. Right. I always find these interesting. I don't know if they're true, but it's cool. So at a depth of x meters, the temperature of the water in the ocean is T degrees Celsius. So at depths below 900 meters, T is inversely proportional to x. So that means as soon as you go down past a certain point, if we get twice as deep, the degrees halve. Hopefully that makes sense. And, oh, actually, we don't even have to find K. Crazy. Okay, so it's been given to us here. So also don't let that throw you off, because this is not in the same format as others. We've actually kind of skipped a step. They've gone straight to, well, this is your K value, this is your formula. So it says, work out the difference in the temperature of the water at a depth of 1,200 meters and the temperature of the water at a depth of 2,500 meters. So we can do this quite easily. So at 1,200 meters, it's going to be 4,500 divided by 1,200, right? Because x is our depth. So I'm just replacing x here. So I really should have written T equals. And that's going to be equal to, let's have a look, 4,500 divided by 1,200, 3.75 degrees. And at 2,500 meters, T equals 4,500 divided by 2,500. And that is going to be 4,500 divided by 2,500, 1.8 degrees. So then it just asks for the difference in those temperatures. So we take the smaller one away from the larger one. So 3.75 minus 1.8, and we get 1.95 degrees Celsius. That's the difference between those temperatures. So that one was actually quite a nice question. Even if you've forgotten everything about proportionality, all this is really a formula question. You're just plugging things in. Let's have a look. Okay. Trying to find another wordy question. Okay, this looks difficult. Let's have a go at this. I'll do this one and then some graphs, and I'll take questions. So, again, this looks horrible. This is a maths question, and the only number that we can see here is 40. So this looks horrible. So a pendulum of length L centimeters has a time period T seconds. And I think this is quite a harsh question because they've thrown in some words that you won't necessarily know what that means at all. The thing is, you don't need to know. All you really need to know is that you have these variables L and T. If you're interested, a pendulum is like something on a, I can see something hanging that I could totally use. I'm going to, 1 second. Look at this, interactivity. So a pendulum is like this, something that swings, and its time period is how long it takes to go from here up and return to here. You totally don't need to know that, but it's interesting, and it's used in physics, so double whammy. So that's all this means, and it's saying that T is directly proportional to the square root of L. So this is kind of the opposite way. This means that if the length of this quadruples, T only increases by 2. So T only takes twice as long to do that. Hopefully that makes sense. That was probably really unnecessary, but I had fun. So the length of the pendulum is increased by 40%. Work out the percentage increase in the time period. So this is horrible. This is a disgusting question. So let's just give it a go. One thing to know, I always point this out when it happens. I'm not fully sure how to answer this question yet. So you don't need to be able to look at a question and see immediately every step you need to do it. What I'm going to do is just think about the knowledge that I have, write it down bit by bit, and hopefully it will make sense. So let's think about what we know. Pendulum, so T is directly proportional to the square root of L. So that means that T equals K root L, right? So it's directly proportional to the square root of L. Now the length of the pendulum is increased by 40%. Work out the percentage increase in the time period. So let's think about that. So let's call this our kind of base case kind of thing, and see what happens when we increase the length of the pendulum. So if you came, well, this ties in nicely, doesn't it? If you came to the percentages lesson yesterday, you'll know that an increase of 40% is the same as multiplying by 1.4. If you don't know that, rewatch yesterday's video. Cheeky plug. So what we can write is that, I guess our new T, let's call it something else. Let's call it N for our new value of T. So here we're saying like our original T is this. So our new T is equal to K. Remember the K will stay the same, root 1.4 L. And now I think we want to work this out so that this root 1.4 is on the other side. So we just have something equals root something L. I think. We're going to do it and see if it works out, basically. So we can write this as n equals k root 1.4 root L. So this is times here. This is from laws of roots. So hopefully you know that. I think I did I do a session on this? Who knows? It's kind of absurd. If things are multiplied in the square root, you can break it up. And then we'll divide. So yeah, okay, I've understood. So we can divide by root 1.4. This is a really difficult question, actually. So now we're saying that n over root 1.4 equals k root L. And hopefully what you can see here is that if we take this and this, so remember this was our original thing. So this is with when the length is just L, we're saying that the period is T. When the length is when the length is increased by 40%, when the length is 1.4 L, the time period is N. That's all these things mean. And what I've done is I've done a sneaky little bit of rearranging. So now K root L and K root L are here, which means that we can just set T equal to N over root 1.4. I hope that makes sense. Hopefully. This is a really, really hard question. I'd say this is level 9. So then N, we're going to multiply by root 1.4 on both sides. So N is root 1.4 T. Let's work out what root 1.4 is. Let's go 1.18. We'll just go to 2 decimal places. So N equals 1.18 T. So let's think for a second. What does this mean? We've just done a sneaky little bit of rearranging and fiddling around to show that N, our new time period, is 1.18 times the original time period. And again, if you were here yesterday, you'll know that this corresponds to a percentage increase of 18%. Hopefully you were here yesterday and you know that. I don't want to dwell too much on how I worked that out. Hopefully that makes sense. Hopefully. Do just shout if you want to go over those. This is a really difficult one. Yeah, people want it to be explained again. So I'm going to take that. I don't know, Tilly, are there other questions? Do you want to should I do another one like this?
There aren't that many today, so I think, yeah, if you go through it again or another one like that, and then, guys, if you have any questions that haven't been answered or any new questions, just pop them in the chat and we can maybe just do a short Q&A at the end today instead of a slightly longer one.
Cool, that sounds good. Yeah, this is a good one to go over because hopefully if you've understood everything that we've done so far, then you're in a really good position. Honestly, this kind of whole topic, this proportionality, it can be like level 6, 7 questions. So if you followed, which I think everyone has, and managed to keep up to this question, you're doing really, really well, especially considering it's Easter. Like, well done. So don't worry if you're not following this. Watch it again, try it yourself. I know that this is really hard. Sometimes I zone out of what I'm saying. I'm like, wow, how am I doing this math? So don't worry, it's difficult. Let's have a look at another one. I don't know if there'll be another one like this on here. So I might have to, I think I might have to come up with one, but that's okay. I can do that. Right. Let's see. Let's say that this is going to come up really small, but I'll zoom in once I've typed it. So I'm just going to keep it simple and not put any context. I'm not going to make it too wordy. What I'm going to say is that, okay, I'm going to do a really simple one, which will hopefully make the other one make a bit more sense? Maybe it won't at all, but this is what we're going to try. Y is directly proportional to X. X increases by 25%. How much? Oh, I'm going to have to do a couple actually. How much does Y increase by? So the point here is that without actually doing any maths, we know that because it's directly proportional, if X increases by 25%, Y increases by 25%. So this is technically a 1-mark question, right? This is just, it's 25%. But I'm going to show you how we would do that mathematically to hopefully make you understand what I was doing before. So Y is directly proportional to X, so Y equals KX. So what I'm actually going to write is our original situation, so Y1 equals KX1. So what I'm saying is these are our original values before any increases. Now when I've increased by 25%, Y2, our new Y value, is equal to K lots of 1.25x1. So what I'm saying here is our new value of Y, this is what we're trying to find, is equal to K lots of, and all I've done here is increase X1 by 25%. This is its multiplier for an increase of 25%. So it looks kind of scary, but honestly, all I'm doing is replacing this with increasing it by 25. And what I want to do is express Y2 in terms of Y1, because then I know how much it's increased. Hopefully, again, that will make sense. So what I'm going to do here is try to make this side just say KX1, because then I can set these things equal. So I'm going to divide both sides by 1.25. So I'm going to write Y2 over 1.25 equals KX1. Right, all I've done is I've just, because these brackets don't really matter because this is all multiplied, I've just divided by 1.25. Popped it over here. Whoop. And now I can do the same thing that I did before, which is saying that this is equal to this. Therefore, this is equal to this, right? I'm just kind of combining these equations. So we're saying that Y2 over 1.25 is equal to Y1. And then multiplying up by 1.25 on both sides, we're saying that Y2 equals 1.25 Y1. And now this is our kind of killer equation. This is what's telling it to us. We're saying that, so Y2 is the value of Y after the increase in X. And that's equal to the original Y1 times 1.25. So Y has increased by 1.25, which is equivalent to a 25% increase. So I guess the goal with these equations is to write the new value of Y in terms of the old value, because then you can work out how much it's been multiplied by. Honestly, it's so fine if you're lost. These are difficult. Watch it again if you want to, because I do think that they're quite interesting. Basically, Y1 and X1 are the original value. I thought I was on the pointer, I'm just drawing everywhere. Y1 and X1 are the original values, and this is it after the increase. What I'm going to do is I'm going to try going over this one. Oh, I clicked the wrong thing. Nice. I'm going to try going over this one again, slightly slower. Because I hopefully, unless, I mean, correct me if I'm wrong, I don't think there's too much point in going over the simpler ones again. Even I say simpler, they're still level 6, 7, but I think there weren't too many questions on that. So I think it's cool if we can tackle this. And even if one person understands this, that would make my day. So let's have a look at this again. What we're saying is that T is directly proportional to the square root of L. So T equals KL. There's nothing new about that. That's just what someone just said they understand it. Oh my God, 2 people understand it. Okay, sorry, wow. Okay, so T equals K root L. There's nothing fancy, there's nothing new about that. That's what we've been doing for the past hour, right? That's just setting it up. So we're saying the length of the pendulum is increased by 40%. Well, for it to have increased by 40%, let's think about what it was before. So let's say, and I'm going to write it over here, T1 L. In fact, we only need one value of L. So T1L is before the increase. And then after the increase, it's T2, a different value for the time period that we don't know. This is what I called N before. And it's going to be 1.4L. And this is all this is saying is that the time period has changed. We don't know what by, and L is increased by 40%. That's all this means. So what we're saying is before we have that T equals K, T1, sorry, equals K root L. And after this increase, well, the time period's obviously changed because it's got longer, and we know that that happens, what I was showing with this. If the length is shorter, it's like that. If you make it longer, it takes longer to swing. So we know that T is different because T is longer. So that's why we've called it T2. And that's equal to K root 1.4L. I could have called this L1 and L2, but we know that this L2 is 1.4 times L. It's 40% more than L. So hopefully you understand the setup of these equations. All I'm saying is that before the increase is this, after the increase is this. And what we can see with this is that this is very, very nearly this. And if we can make these things equal, we can set these things equal. Because that tells us about the increase in the time, in the percentage increase. Because it's like what we're saying with L, right? If we call them L1 and L2, we're saying that L2 equals 1.4 L1. So we want to know what the equivalent of that is for T. How many times bigger is it? How much longer does it take when L is 40% longer? So what we're going to do is do a little bit of fiddling around with this equation. So this is just a bit of algebra, really. We want to make this right-hand side say K root L. So I'm going to multiply this out and make this K root 1.4 root L. I don't want to focus too much on this, so this is just the way that we rearrange it. I'm just separating out that surd. Sorry, I should have said T equals. We'll keep it as the equation. So T2 equals that. So T2 over root 1.4 equals K root L. Hopefully you understand this bit of rearranging. All I've done is split up the surd and divided by root 1.4. And what that's given me is 2 K root L's. So we can say that these two things in the pink squares are equal. T2 over root 1.4 is equal to T1. So multiplying up by root 1.4, T2 is equal to root 1.4 T1. This longer time, so let's say that this is our length L and this is our time T1. We've increased L by 40% and it makes T2. Now this T2 is root 1.4 times bigger than this T1. It takes root 1.4 times as long. That's what we've learned here. And now we just want to express that as a percentage. So we're going to work out what root 1.4 is. I don't know why I'm doing it again. We know it's 1.18 because we did it before. So T2 is 1.18 T1. So what I'm saying is that this is L. This is T1. We increase L by 1.4. That's 40% more. Then we increase T1 by 1.18 because of this square relationship. This is what we've worked out. This is our T2. And this is 1.8 times as much as this. And then what this means, again, yesterday from the multiplier, in a similar way to how 1.4 represents an increase of 40%, 1.18 represents an increase of 18%. So what we've done there is we've just thought about the relationship. We've just called this T1 and this T2, and this length L and this length 1.4L. fiddled around with the equations a tiny bit, and we worked out that we've got here, and then when we increase this by 40%, this increases by 18%. Okay, cool. People are saying that they understand it. Yay. Okay, brilliant. Don't worry if you don't understand still. Give it a watch again. And don't worry if you can't. Yes, loads of people are saying they understand. Oh my God, that actually makes me, that makes me so happy, guys. Oh my gosh, stop. I'm such a nerd. This makes me so happy. Right, okay. Are there any other questions that anybody has? If not, I can go over graphs, the proportionality graphs.
Yeah, there were only a couple of questions, I think. Someone asked, can questions get harder than this?
I don't think so. I don't think so.
Ian, what year do you think we would learn this? Someone asked.
Oh gosh, good question. I don't know when you learn proportionality. Year 10, maybe? And then I guess this is more like year 11 level stuff. I'm not 100% sure though. Might have changed.
Cool. I think in that case, Molly, do you think there's time to do one percentages question for the last sort of 4 or 5 minutes?
Yeah, sure. What one like this?
So a couple of people have asked, so someone said, can we do more questions like this? Someone asked for more questions like this with percentages, but whatever you think will be best.
Okay, sure. Yeah, I'll do one like this with percentages. Cool. Okay, I'll come up with one again. Okay, I'll do one again without the all the wordy stuff. We'll just do a direct relation. So let's. Oops. Okay, what are we going to do? Now, is that going to work? Yes. Okay, just got to think really quickly. So let's say, let's make it a bit wordy. Let's go for it. I'm just going to do a ball being thrown up again. So, okay. A ball is dropped from height h and hits the ground with speed v. H is directly proportional to the square of v. H is, let's just say, the ball is dropped from, what should we go for? 34% higher. Let's just go crazy. What is the percentage increase in the speed at which it hits the ground? Gosh, you can see why I pre-prepare questions, right? That was painful. Okay, so all this is saying is that a ball, this is glass, so I'm not going to drop it much, but ball is dropped, and the higher you drop it from, the faster it's going by the time it's hitting the ground. And this is proportional to the square. I don't know if this is true at all. So what I'm saying is that if you drop it twice as high, it's going 4 times as fast when it hits the ground. So let's do this in the same way that we did our other ones. So we're going to think h is directly proportional to the square of v. So h equals k lots of v squared. Cool. Again, that's just what we've done before. Now, the ball is dropped from 34% higher. Well, let's think about what it was originally. So originally, we'll call our height h1. So we've got this first height when it's at its normal level, because for something to be 34% higher, you've got to think about what it was originally. So we've got our height h1, and that's equal to k lots of v squared. Just call that speed when it hits the ground. That's just v. So h2, I've made this a bit wild, haven't I? Right, I want the other way, sorry. H is direct. Okay, I should have written this the other way. I should have said v is directly proportional to h. The speed is directly proportional. I wrote that the wrong way around. I apologize. V is directly proportional to the square of h. Nothing I've said so far has been incorrect. If you drop it from twice as high, it's 4 times as fast when it hits the ground. More examples of why Molly shouldn't come up with questions on the spot. So V is directly proportional to the square of h. V equals kh squared. So we've got V1, that velocity, that first velocity, and that's equal to k times the height squared. So this is before the increase, our kind of base height, whatever we are. And now we're getting 34% higher. So it's going to have a new velocity. We don't know what it is, so we'll call it V2. But we've got 34% higher. So we know that that's 1.34 times that h. So instead of h, it's actually 1.34 h. Again, we could have called this h2, but we know h2 in terms of this first h1, we know it's 1.34 times more. That's how we're writing it. This would also work with the decrease, by the way. This would just be the multiplier below 1. Again, watch yesterday's. And now we want to do the same thing. We want to make this look exactly like this so that we can set these things equal. We want to know the relationship between V1 and V2 because then we know what the increase was. So let's do some fancy, it's not fancy algebra. What we're going to do is we're going to say that this is 1.34 squared h squared. All I've done there is I've squared both bits in this bracket. So then I can say, I'm just going to divide both sides by 1.34 squared. I'm not bothering to work it out yet because I can't be bothered and we don't really need to until the end. So V2, our new velocity divided by 1.34 squared equals kh squared. And now lovely, these two are equal. So we can set these two things in the circles equal. So V2 over 1.34 squared equals V1. So we just want to quickly make this V2 equal. So V2 equals 1.34 squared V1. So what that means is that our new velocity is 1.34 squared times the time of the first velocity. So what is that? It's 1.7956. 1.7956 V1. So if we increase this by 34%, if we get 1.34 times higher, the velocity is 1.7956 times more. It's going a lot quicker. And again, we can just quickly see that this translates into a percentage increase of 79.56%. Again, look yesterday for multipliers if you want to. And all this has told us is that, so we're at this height and it falls with this speed. So we're here, that speed was the original speed. I've increased this by 34%. That speed increased by about 80%, 79.56%. So it's really similar to the other one in the way that we did it around. So cool, I think I've actually run over a lot, but hopefully it made it make sense. And hopefully we will have so thank you very much for coming.
Brilliant, thanks so much, Molly, and thanks for coming up with those questions on the spot. I did put you on the spot there.
That's okay.
Brilliant, thanks so much, guys. Lots of good stuff today, lots of difficult stuff, so well done for keeping up. As I mentioned at the beginning, we've got another couple of sessions. Today we've got GCSE Physics at 2 and GCSE Biology at 3:15. So if you'd like to join us for either of those, please do. If not, then have a lovely bank holiday weekend and we'll see you again next week. Just keep an eye on your emails for the timetables for the next lessons. But have a lovely afternoon and thanks very much, Molly.
Cool. Thank you, everybody.
Bye.